expressions. Now, factoring is a skill that you're going to be doing over and over again in all different levels of mathematics. Factoring is basically when you break something apart into its components. All right? We sometimes factor to solve equations or to find roots of functions or to simplify rational expressions. We use factoring all the time. So the first kind of most basic form of factoring is factoring out a GCF, or greatest common factor. I think of this as undoing distribution. That's really what factoring out a greatest common factor is the undoing of distribution. So for example, if I have 3 times x minus 7, right? I could distribute that 3 and say, oh, that's 3x minus 21, right? So this guy is kind of my simplified version, we sometimes call this. This is the factored version, where I've broken it up into its factors, into its parts. All right? So if I gave you 3x minus 21 and I said factor this, I'd show you this. If I gave you this and I said simplify or expand this or multiply this out, you'd go in this direction, right? So sometimes we want it all nice and cleaned up, and sometimes we want it in the factored form. So now GCF, again, you think undoing distribution. So if I had something like this, let's make this a little more interesting. Okay, I have 2 terms. A term is just a blob of things multiplied together. And terms are separated by either addition or subtraction. So if I have 2 terms here, and if I want to factor this, I look at this and say, hey, these 2 terms have some things in common. They both have a 5 as a factor. Both terms have an x. Both terms have a y. So if I'm going to factor this, I'm going to factor out a greatest common factor of 5xy. And then I figure out what's left over. So if I'm dividing out a 5 from a 15, that leaves me with a 3. X squared divided by x leaves me with an x. Y divided by y leaves me with 1. Bring down that addition. I'm factoring out or dividing out a 5 from that 10, leaving me with a 2. X divided by x is 1. Y squared divided by y, y. That would be fully factored. Okay? I started with 2 terms. When you factor things, you are always left with 1 term. Believe it or not, this big gross looking thing is 1 term. It's a blob of things multiplied. 5 times x times y times the quantity 3x plus 2y. This is 1 term. This is 2 terms. Okay? So GCF is the first type of thing, the first type of factoring we should always look for. You know, and you can have a whole string of terms. I'm into 21s evidently today. How many terms do I have? I have 3 terms here. I want to factor, I see right away, oh, there's a 7 in common. Let's see, there's an A and an A in common. I can take out a 7 and an A from everything. That leaves me with a B. 14 divided by 7 is a 2. A squared divided by A. 21 divided by 7 leaves me with a 3 and a B. So again, this would be my fully factored form. Ooh, nice alliteration. Fully factored form. Right? Now, a GCF can look a little weird. So for example, if I had something like this, how many terms do we have? Well, I'm seeing 2 terms. This is a blob of things multiplied, 5 times a plus b, that's 1 term, minus, here's a second term, x times a plus b, 2 terms. What do those 2 terms have in common? An a plus b. That's the greatest common factor. So just like I was factoring out a 7 from the last one, I'm going to factor out my a plus b. Boom, I'm factoring that out. Big parentheses for what's left over. Well, my first term, if I'm dividing out an a plus b, I'm left with a 5 minus. My second term, I'm dividing out an a plus b. I'm left with an x. There you have it. So sometimes your greatest common factor is itself a binomial, right? It doesn't just have to be one term. It can be a binomial, such as that. Let's do another one like this. Let's say I had, I don't know, something like x squared times 3x plus 1 minus 16. Let's make this even more interesting. 3x plus 1 cubed. All right, again, I have two terms. I guess I'm into two terms today for some reason. What do those two terms have in common? Yeah, 3x plus 1 to the third. They both have 3x plus 1 to the thirds. That's going to be my greatest common factor. I'm going to factor that out. I'm going to pull that 3x plus 1 to the third out front. What's left in this first term? X squared minus what's left in the second term? 16. Now, I hope you are looking at that and saying, hey, Ms. Stewart, you're not done factoring. You factored out a greatest common factor, but you can keep factoring, and you're right. I hope you're recognizing this is one of our old friends, difference of perfect squares. I used to love these when I was in high school. Call me strange. I know you have already in the past. X squared minus 16, our good old difference of perfect squares. We know how that looks. So sometimes when you're factoring out a greatest common factor, that's the first step. And then you have to make sure that each factor is fully factored. So that bottom line would be a fully factored version. So again, I started with two terms. When I'm fully factored, believe it or not, that last line there is one term. It's a blob of things multiplying. All righty.
Was it the